Hello again. And so there's going to be two basic types of questions we're going to see with parametric equations, at least to start. The first type is we're going to eliminate the parameter. So what we're going to do when we eliminate the parameter is we're going to turn our parametric function into, our parametric curve into a regular function we're used to working with without the parameter, so just involving x's and y's. Okay, so I'll show you one that's a little bit tricky to begin with, and then I'll show you how this more or less works in general in a slightly simpler example. Okay, so let's look at this. So we have our equation of our circle from before. Okay, if we draw this out, should look more or less like this. There's our orientation on the curve. Okay, so ideally what we want to do is we want to somehow isolate t, but in this example we won't be able to. Okay, but we do know a very famous equation involving cosine t and sine t. We do know that, I'll write it like this, cosine squared t plus sine squared t is equal to 1. Okay, but we know x of t is cosine t, y of t is sine t, so we can write it like this. So x of t squared plus y of t squared is equal to 1. And what we normally do at this point is t is no longer necessary here. So we would say x squared plus y squared equals 1. Okay, and that's the equation of a circle that we're used to seeing before. Okay, so this is more or less a special case. We needed some sort of a way to relate uh, our x of t and our y of t together into a single equation. Okay, let's look at another example and see how this is going to work more in general. Okay, so our curve is going to be x of t is equal to 1 minus 2t, y of t is equal to 1 half t minus 1, and we're going to have t go from negative 2 to 4. Okay, so what we can do is we can isolate t in either the x equation and the y equation. We're going to substitute it into the other one. Okay, just because x comes first, I'll do this. So I'm going to write x is equal to 1 minus 2t, and I'm going to solve this for t. So that means x minus 1 is equal to 2t, and x minus 1 over 2 is equal to t. Okay, and I can substitute that into my y equation. Okay, so y is going to be equal to 1 half times x minus 1 over 2 minus 1. Okay, and we can simplify this a little bit. So y should be equal to, what is this? This is going to be x over 4 minus the fourth minus 1 becomes minus 5 over 4. Just quickly double checking my arithmetic. There was a minus sign there. So that's a minus sign. This is all multiplied by minus 1. So that's multiplied by minus 1. So this becomes minus 3/4. Okay. Okay, but let's draw this out. So first off, we know looking at this is a line, because that's y equals mx plus b. Okay, so if this is a line, we can plug in our endpoints and we can just connect them with a line. Okay, so we know x of -2, y of -2 should be equal to 5 -2, and x of 4, y of 4 is going to be equal to -7, 1. Okay, so that means go 1, 2, 3, 4, 5, down 2. And then we go 1, 2, 3, 4, 5, 6, 7, and up 1. So what does this curve do? You can pretend that this is a straight line, and it does this. Okay, so this brings up a very interesting point. There are many, many ways, or in fact an infinite number of ways to write this parametric curve of this line segment. Okay, what we want to do is we want to do this in a nice practical way. And this seems as good a time as any to do this. So in parametric form, the equation of a line for a line segment from, we'll call it x naught, y naught to x1, y1 is, again, there's many ways to do this. This is by far the easiest. At least this is the way I remember it. X of t is going to be t times, write it like this, 1 minus t times x0 plus t times x1. Y of t is going to be 1 minus t times y0 plus t times y1, and our parameter t is going to go between 0 and 1. Okay, to verify that this is in fact the same as the line you would get, you need to eliminate the parameter. That sounds like an excellent homework problem that your very intelligent professor would ask you to do. So that's on the written homework. And that's all for this. And we'll go ahead and look at the second type of problem you'll see about parametric equations. Thank you.